Hello everyone, thank you once again for joining me. It is January 9th. Today I'm going to be doing LeetCode problem 712, ASCII delete sum for two strings. Let's get into it. Given two strings, S1 and S2, return the lowest ASCII sum of deleted characters to make two strings equal. Example 1, we have C and eat. The output is 231. Deleting S from C adds the ASCII value of S115 to the sum. Deleting T from eat adds 116 to the sum. At the end, both strings are equal, and 115 plus 116 equals 231 is the minimum sum possible to achieve this. So to make two strings equal, they mean removing S and removing T. The string S1 would be EA and string 2 would be EA as well. So then they're equal, and the minimum sum is 231. Okay. Example 2, delete and leet. Deleting DEE from delete to turn the string into let adds 100 from the D, 101 from E, and 101 to the sum. Deleting E from leet adds 101 to the sum. Both strings are equal to let, and the answer is this sum of 403. If instead we turn both strings into Lee or T, Lee or eat, we would get answers 413 and 417. So if we were to delete a character, the relative position of the letters in each string have to remain the same, meaning if this is A and E and this is E and A, the two strings are not equal. They have to be EA and EA. So how can I find subsequences of S1 in S2 or S2 in S1 so that we can have the minimum sum and both of those strings being equal? Well, in order to be equal, they obviously have to have the same characters in the same order. And we could surmise from example 1 that S is not in the word eat. Therefore, the two strings can't be equal. So we would have to remove the S. Likewise, T is not in S1. Therefore, we'd have to remove that from S2, resulting in two strings that are both EA, and then they're equal, and then we just take the sum of the ASCII values. So I think an issue with the way the problem is, the rules of the problem is that why not remove the A as well and the A as well, resulting in a string S1 equal to E, S2 equal to E, and wouldn't that make the minimum sum when you take the ASCII values of E in both of these? Okay, well, in example 2, we see that DE can be taken out of S1 because the relative order of S2 needs to be within S1. So DE can be taken out, and then we see there's a string called let, and S2 has leet, but the substring let only has one E, so we'd have to remove the E. And then we have LET and LET. So what I'm thinking of right now is that, say we have a dictionary, 2 dictionaries containing a key of, or excuse me, the letter the letter is the key in the dictionary, and the value is the number of occurrences of that letter in each string. Excuse me. The first dictionary has a key of the letter and the occurrences of that letter within string 1, and likewise the other dictionary does the same for S2. And then we need to find a way to begin removing characters from each string and removing them from the dictionary, so that eventually we can have a dictionary, 2 dictionaries that equal the same. But that's not enough, because we need to ensure that the relative order remains the same. So let me just create an example of this, because that may clear some things up. So we have 2 dictionaries. This represents the first dictionary, and this is the second dictionary. And then we have a key of S, value 1, E occurs once, A occurs once, E occurs once, A occurs once, and T occurs once. And these 2 dictionaries, they're not equal. Therefore, the strings can't be equal, because either this letter is not in this dictionary, this letter is not in this dictionary, or the counts could be different, resulting in 2 strings that are not equal. So say, for example, we remove S because it's not in S2. We remove T because it's not in S1, but say S1 was the string EA and S2 was the string AE. They would have the same character count in each, same length, but the positions would be different. So how can I find a way to ensure that the positions are the same. While also making sure I'm getting the lowest ASCII sum of the deleted characters, because maybe this implementation doesn't account for that. I thought I wasn't recording for a second. Okay. So now that we have these two dictionaries, what if we were to iterate through both of the strings? So we see S. Is the character S in the dictionary S2? No, it's not. So we can delete it. And we would also need to have, assuming we're iterating through these strings and checking if the character is within the other dictionary, we need to iterate through them and have some variable that tracks what index we're on. So S is not in eat, so we can remove it. We move this over to E. E is in eat, but is, so we could then check if the position of E is at the same position of this E. Or excuse me, if the position of the current letter we're on in S1 is the current letter we're on in S2. So that works for that. So then we can move over to A. The current letter that we're on in S1 is the current letter in S2. So we can move that over. And we see that we're at the end of S1 and there are no more characters to iterate on. So then we would remove each character after and including the character we're on in S2. So we remove T and anything after T. And then we compare the dictionaries, and then we see that the dictionaries are the same. So then we take the ASCII value of each character. And we could have done that before as we're iterating through the string, and then just take the count times 2, because there are two strings that equal the same. But I can just calculate it at the end, and then I'll refactor the code. So far, that's the current implementation I'm going with. But will that work for example 2? So this is example 1, example 2. Okay, so this is example 1, and this is example 2. And then we create the dictionaries again. So we have D is 1, E is 2, L is 1. E is 3 actually. T is 1. And then L is 1, E is 2, T is 1. Okay, so let's just iterate through. I'm not sure if, I think we can iterate through D1 first. I don't think we need to iterate through the minimum, or excuse me, the string of the lesser length. But maybe. But let's just see if this will do. So we have two variables that track the index, and as we're iterating through them, we move them by 1 over. So D, is D in Leet, or is D in the dictionary of S2? No, it's not. So we would actually reduce this by 1 equals to 0, and then if the key of D within the S1 dictionary equals to 0, then we just delete the key value pair entirely and then move 1 over to E. Okay, is E at the index that we're on? No, it's not. So then we subtract 1, move it over. Is L at the current index? Yes, it is. So then we can move both of them over. Is E at the current index? Yes, it is. Move them over. Is T at the current index? No, it's not. I think I'm running into an issue. T is not at the current index. So would we remove T or would we remove E? And in that case, I suppose that is the place where we would determine if the ASCII value of T versus E was the greater of the values. Because since we want the minimum sum, we would want to subtract the maximum ASCII value of the letter. So that's the one change that I need to make in my implementation. Let me make a note of that. So when comparing letters in each other's dictionary, if character not in other dictionary, compare ASCII values and delete the greater of the two. Okay. So then T is not the current value in S2. So instead we remove that. And then we move over. Is E the current value? Yes, it is. So then we continue iterating and continue iterating. Now is T in S1? No, it's not anymore. So we remove everything and including that. Well, excuse me. No, we remove that and then we continue iterating and then we see there are no more strings. So that works. They're both, the dictionaries are the same, and we add up the remaining letters, or we get the ASCII values of each letter in the dictionary times the count of them. So we get the ASCII value of L and E twice, and then we repeat that again because we need to take the sum of both of the dictionaries of the ASCII values of all the keys in both dictionaries. That may have been a little confusing. Okay, so I think that my solution intuitively is correct, but I'm not positive, so I want to run it through again. I want to talk it out again because yeah, I want to make sure that it's all solid. So okay, so we're going to run it through again. So is the current value of D in dictionary 2? It's not, but then it's not at all. So we need to delete that anyways. So that's a good note as well. So if character not in the dictionary at all, we need to remove it and index over of string that removed it. So one second. Okay, so D is not in Leet. So we remove that. Okay, so D is not in dictionary 2 at all. So I don't think we should remove it yet. I think we should just subtract it by 1. So that gets subtracted. That's 0. And because it's 0, we remove it. And we iterate over. E, is that in Leet? It is. But it's not at the current position. So in that case, L has a greater ASCII value. So that's interesting. E is in the dictionary. So how would I choose to remove E versus L? You know what? I just realized that I made an error in that I was adding the letters that were left over, but instead we need to add the letters that we're deleting. So that's a major issue in the solution, and I should have acknowledged that before. See, we're deleting, in this example, deleting D, E, E, and they're taking the sum of those. So it's a complete oversight that, that's an immediate fail. But nonetheless, this is just we're just practicing, so not as serious, but still. Okay, so we know we need to delete the D. So then let me go back a few more. So we know we need to delete D, at least by 1 right now, because D is not in S2. So this turns to 0. We add the sum of 100, the ASCII sum, 100, and then this gets removed from the dictionary. We move D over to the next index in S1. And then we're at E and L. Is E in the dictionary of S2? Yes, it is. Is it at the same spot of S2, of the index in S2? It's not. L has a greater ASCII value. But what else? How else can we deduce that we need to remove E? There's 3 E's, and S2 has 2 E's, but that doesn't necessarily mean we need to remove. It does mean we have to remove at least 1 E from S1. But how do I know this is the E that we need to remove? Maybe we know it's the E we need to remove because if it wasn't, then it would be at the same index in S2. Can I go with that though? Is that logical? Okay. E is in S2, L is in S1, and the amount of L's are the same. Is that enough though to say that? I don't think that's enough to make the deduction that we remove E. Well, wait a second. A, B, C, D, E, and L. L is the minimum of the 2 in terms of ASCII values. So is that the thing? Is that the solution? So we remove E and we add 101. Or excuse me, we reduce E by 1. That's not 2. Add 101. Move the index over. Now we're at L. The positions of L relative to the index that we're currently on in each string, they're the same. So we move both of them over. E, the positions are the same. T is in S2. They have the same value in the key value pair. T would be the greater of the two sums, or the greater of the two ASCII values. And we want the minimum ASCII value. So in that case, we remove the E. Yes, because it's the minimum. So 2 gets decremented to 1, add 101 again, move this over. T and T are the same, at the same position. Move this over and move this over, and then, is that it? Oh, wait a second. And then we need to remove the remaining E from delete so that the dictionaries are equal. So that gets set to 1, and we add 101 again, and then we move this over, and now both of the indices are past the amount of letters that each string contains, and we return the resulting sum. Okay. That looks good so far. I think I've explained the process well enough. Let me see, we're at 33 minutes. Okay, well, let's get started. First, I'll import the collections library, or excuse me, the default dictionary. From collections, import default dictionary. And we'll say s1 dict equals default dictionary s1, s2 dictionary equals default dictionary s2. We'll say min sum equals to 0, and then we return the min sum at the end. And then we say s1 index, s2 index equals to 0 and 0, and then I'm thinking we should do a while loop that iterates through the strings until both of the index positions are greater than both of the strings. So I'll say while s1 index is greater than length of s1 minus 1, and s2 index is greater than length of s2 minus 1. So then once we reach a point, like in example 2, when s2 has iterated through to the end of the string, but s1 remains, we can continue iterating through to finish off that last string. Okay. One thing that I am forgetting is how to get the ASCII value of a string, or of a character in a string. Yeah, I don't know how to do that. ASCII value isn't the same as using the OR function. Okay, so then I can begin iterating through both of the strings. So I'll say if S1 S1 index, if it's not in S2 dictionary, such as the case in example 1, S is not in EAT, then we have to remove it, or at least decrement it. No, that's not exactly the case though. If S1 is not in the dictionary, we decrement it. We can just remove it if it's not in the dictionary. So we'll say I don't think we should entirely remove it though, because I think decrementing the value in the S1 dictionary by 1 is better, because if we just remove it entirely, then I don't know, I feel like something is off with doing that. Yeah, I can't explain it, but I'm going to do that instead. So we'll say, so this is S, so we'll say S1 dictionary S1 index minus equals to 1. If that value equals to 0, then we need to remove it entirely. S1 dictionary, what is that? Delete S1 dictionary. Yeah. Delete the S in S1 dictionary. For some reason this is looking a little bit funky to me, and it's probably because how I named the variables S1. It's a bit repetitive. Okay, and then regardless of that, we need to move the S1 index over. So that becomes an E, and we're at E in S2. D is not in S2, So we move that over to E. I'm going to copy this over. So we removed D. S1 index is now at E. E is in Leet. But they're not at the same position. So if they're not at the same position, this condition is E is in Leet. If S1 index does not equal to S2 index, they don't equal the same, so we want to remove the minimum of the two values, of the two characters, E and L. And we can find the minimum using the ORD function, which returns the ASCII value of a single character. So we'll say if the ORD function of S1 index is less than the ORD function of S2 index, then we want to remove S1 index. So we'll say S1 index within the dictionary minus equals to 1. Else, if the ORD function of S2 is less than S1, then we want to remove 1 from the count of S2 index of inside of the string S2 in the S2. See, the naming convention is, I did a bad job in that, but yeah, so we're reducing the value by 1. And then if that's the case, then the min sum gets incremented by the ORD function of this character. Likewise, the same happens with S2. And then once again, if the count of that is 0, we remove it entirely. Same with S2. And then we still have to increment the index. S1 index plus equals to 1. S2 index plus equals to 1. Now if they're the same, if the two values are the same, else if the two values are the same, S1 index plus equals to 1, S2 index plus equals to 1. And then that should cover most of the solution. However, we need to also make sure that we're not getting any out of bounds errors. because as we saw in example 2, delete has a greater length than leet, so we need to take account of that. Okay, let me make a mental note of that. We do need to refactor. I believe we should, but I want to take a note of making sure we're not out of bounds. So we're iterating. I'm wondering if maybe and isn't the right option. Because if it's an or condition, then once an index is outside of the length of its respected string, then we break out of this loop, and then we can then just check if the index of each string is within, if it's less than the length of the string, then we can deduce that that is the string that we need to take off the remaining letters from. Then we can deduce that that is the string we need to take off the remaining letters from. So I'll say if S1 of index is less than length of S1 minus 1, then minsum plus equals the ORed function of S1 index plus equals to 1, and the same with S2. So only one of these conditions will run or may not run, because both of the strings could be the exact same, meaning that we break out of this loop, but we never have to hit either of these while loops. Okay, so let me revisit this solution. I'll give myself only a few more minutes. So we create the dictionaries. We begin. This is a mistake right here. While both of these indices are less than the length minus 1, if S1 of S1 index, which is S, oh, okay, no, we're still good. If S is not in S2 dictionary, which it's not, we have to remove that regardless. So we subtract the count of that character by 1. If it equals to 0, we delete it entirely. We move that index over. Else, if I'm wondering if I should add another conditional statement, seeing if the S2 of index is not in S1 dictionary, but maybe that's redundant. Okay, a better example would be to go through example 2. So D is not in Leet. Subtract the count of D by 1. Subtract the count of D by 1. Delete it from the dictionary. And then we didn't add it yet, so we need to do that. Min sum plus equals to the ORed value of, even before we do that. Actually, this would be better. Move it right here. Okay. So we remove D. Now E and L. E is in S2, but the positions of the current index of S1 index and S2 index, the values aren't the same. So E has a lesser ASCII value than L. So we hit this condition. And if that's the case, we reduce the count by 1 for E. We add E to the minimum, the ASCII value of E to the minimum sum, and we move that over. So now that's L. And then we go through the loop again. And now they're both at L. L and L. So then we increment the indices. So now they're both at E. And we increment the indices again. So now we're at T and E. And we reach this condition again, the else statement, because T is in the remaining string at the end though, but still we reach this condition. The values are not the same. S1 index in S1 string has a greater ASCII value. So we remove the E in S2 because it is the lesser of the two, and we want the min sum. And then now we're at T and T, no pun intended, because I'm bombing this problem. That's the pun. T and T, they are the same, so we increment by 1, and now it's E, and now we're at the end of S2. There aren't any more, so we break out of this loop, and while S1 index is less than the length of S1 minus 1, less than or equal to, it should be though, right? Okay, we'll come back to that. Min sum plus equals the ORed value of E and everything after that, because we have nothing to compare it to. Therefore, we have to remove each character from the dictionary and sum up each ORed value of that character to the min sum. That all looks good. I do need to pause right now because I told my friend I'd go to the gym with him in 13 minutes. So, okay, everyone, I am back from the gym. So let's finish what we started. So if my memory serves me right, I was hung up on the indexing of some of these loops. Let me just refresh my memory with what I did. So the while loop continues until either of these indices are past the point of their length of the strings. If the index is, while the index is less than, this is actually, while the index is less than the length. That's fine. And then, while s of index is less than the length, that's still good. And that is still good. So I think this is ready to run. Okay, let's see. Import default dictionary. Default dictionary, isn't that correct? From collections, import default dictionary. That's spelled correctly. First argument must be callable or none. This is a, I don't think it's a capital. Oh, what am I saying? It's not import deep, it's import counter. Okay. If S1 of S of index is not in S2 dictionary, while it's less than the length, I see. I think that this does have to be and then, because if we've gone past the length of S1 and we're still using this conditional statement, that would be out of range. Okay. Yes, that's correct. And then as soon as one of them is out of range, then we go to these while loops. Okay, let's see. If S1 S of index not an S2, it is so we enter this loop. If S1 S of index does not equal to that, if the ORD function of S1 of index is less than the ORD function of S2 index, which it is, then we reduce the count. We don't need to delete it because there are more C's in the dictionary of S1, and then we add the ORD value, and then we increment the index. See, this is a hard example to understand where my logic went wrong. It's got to be, I feel like this is the case in that I'm only checking if if this letter is not in the dictionary, as opposed to checking if the S2 index letter is not in S1 dictionary. But a lot of this code looks redundant. So, and I know the variables are kind of, they're poorly named. It's hard to look at. Even if the code got to this part, there isn't even enough letters in, say, S1. We finished the iterating over the string. There aren't enough letters to reason that adding the ASCII value of these letters would result in a difference of 390. So it's not like this is the problem. I'm only going to take another minute to think about this, and then I'm going to have to run it through ChatGPT. Yeah, this has got to be the problem. If S1 index is not an S2 dictionary, I still need to compare the ORD values, because why would I assume that the character in the S1 string is the one we need to reduce or decrement? So I'll say, yeah, so this is getting to be what they call spaghetti code, right? Well, you know what? Why don't I just implement this conditional statement within this conditional statement, and then maybe we can find a way to simplify that. But wait a second. If they're not equal to each other, I'm doing two different things. I'm checking if the character is not in the dictionary, but then here I'm checking if they're not equal to each other. So, based on that alone, if they don't equal each other, why don't I just remove this? Okay. So they don't equal each other. So, which one to remove then? We know that if the character doesn't exist at all, if character F does not exist in S1, we need to delete it regardless. They don't equal each other. They do equal each other. Then we just increment. Okay. If F is not in S1, okay, if S1 index not in S2 dictionary, then we know we need to reduce it from S1 dictionary. That's a fact. You have to remove it regardless. So S1 dictionary, S1 index minus equals to 1. Min sum equals that index, S1 index plus equals to 1, and okay, if we can do the same with S2, Else if it is in the dictionary, then okay, if it is in the dictionary but they don't equal each other, then we remove the one that has a lesser OR value. If it is in there but they don't equal each other, then we remove the one with the lesser OR value. Getting convoluted again. I'm sure I can eliminate some stuff. If it is, if the value is not in the dictionary, it is in the dictionary, but they're just not in the same spot, then compare. Yeah, I don't like the way that looks at all. The way I set this up, maybe this is completely necessary though. Let's just run it and we'll see what happens, and then hopefully we can refactor it. But I'm reaching that point where my brain is too fatigued. Okay. Is my brain that burnt out? It's possible. Though I have been programming in Go as well, so. Right. Okay, so I'm going to go back to my original solution, the one that ran and got a few cases right, and then we'll go from there. Okay, yeah, let's see what I could have worked on, what I could have improved on. Delete the characters so both strings become the same. Greedy comparisons of ASCII values does not guarantee global optimality. That's a great point. Yeah, so I thought that my getting the count and then tracking the index of each string would be a good solution, but yeah, this is kind of what I talked about earlier on in the video. It's meaningless globally. Passive character now might enable keeping many future matches. Okay, guys, I'll be fully transparent in that I am not great at dynamic programming. So if you guys don't want to see the answer, then stop watching now. So let's see. Yeah, this is a bit too convoluted for me. Is convoluted the right word? I don't even know. I may have to come back to this tomorrow. Well, guys, I tried. I did not succeed. Yeah, I'm gonna post this video anyways because that is the name of the game. So, thank you for watching, and hopefully, if you're working on this problem, you were able to come up with something. If not, well, it's alright. Onward we go. Thank you all for watching, and I hope you have a fantastic night. I need some sleep now. Take care.